Welcome to 4th grade, Unit 2, Multiplication with Whole Numbers. Please have this note sheet ready and a notebook to take some good notes and do some extra practice problems throughout this video. Here we go. The first topic is area. This is not a new concept, but one that we should be reminded of yet again. Area is the base times the height. Remember, the base is where the object rests on. So it could be the bottom of the shape or it could be the top. In this case, it's the 6 units of the top times the height. And the height is always 90 degrees from the base. So our height is 4. So we do 6 times 4 to get our area, and our area is 24 square units. If we know what the unit is, then it would be squared whatever the unit is. Maybe it's inches, square feet, squared centimeters, whatever the unit might be. But if we don't see a unit, then we know we need to write just squared units then. All right, let's look at our example. We're going to do base 7 times height 4 to equal our area. So our area is going to be 7 times 4, which is 28. So our answer is 28. And now we look, and they said that this was a measurement in inches. So since it's area, it's going to be inches squared. There's many ways you can write out the inches squared. The fastest one is inches with the little exponent 2 behind it. You could write out square and then inches, or you can abbreviate and write SQ dot IN dot, because that would represent square abbreviation and inches abbreviation. All of those are acceptable, but the one that I wrote under find the answer or find the area would be the easiest or quickest one, as long as you put the exponent behind the unit, because we're squaring the unit, not the number. Our next concept goes a couple levels deeper than the area problem that I had just shown. So this one, let's move this out of the way a little bit more. This one goes into 2-digit by 2-digit multiplication using the area model. So we're still using the concept of area, base times a height. So we first need to take our number 27 times 13, and we need to expand them out. We are going to get 10 plus 3 is 13. 20 plus 7 is 27. So I'm keeping the same digits with the same numbers across the top or across down the side. We're going to add those plus signs in, because if we're expanding it out, we would have those plus signs in on every single problem. I also like to say that where the plus sign is where we draw our box lines. The next step is to multiply. So I'm going to multiply the area of each of these boxes. This first box has a height of 20 and a base of 10. So 20 times 10, 200. This next one has a height of 20 still and a base of 3. So 20 times 3 is 60. The next one has a height of 7 and a base of 10, 70, and a height of 7, a base of 3, 21. The very last step is to add all our partial products together. So we're going to add the 200 plus the 70 plus the 60 plus the 21, and we end up with our answer of 351. Let's try an example. All right, step 1, we expand our problem out. So we get 34 is 30 plus 4. And where I saw the plus sign, I'm going to draw a line. And my other one's going to be 80 plus 2. And again, a plus sign, so I'm going to draw my line across. In the first box, my height is 80 times my base is 30. Well, 8 times 3 is 24. And I had a 0 in 80 and a 0 in 30. So that's my quick way of going. I like to circle those answers right within the box too, so I can find all my partial products. The next one over here is going to be 80 is the height times 4. 8 times 4 is 32. And we had 1 0 in 80. So we have 320. My next one's going to be 30 times 2, which is 3 times 2 is 6. And we had 1 0 in 30, so 60. And my last one is 2 times 4, which is 8. Now we found all the partial products. Our last step is going to be to add them up. This is the part that people probably make the most mistakes on because they do not always line their numbers up with the correct place values. Using line paper where the lines are making your columns can be very helpful if you have a hard time lining up numbers into columns. So we're going to add all these together. 8 plus nothing, we get 8. 6 plus 2, we get 8. 3 plus 4, we get 7. And 2 plus nothing, we get 2. So our answer of 34 times 82 is 2,788. The next thing we're going to look at is the traditional method. So the first method I just showed you, the area model method, is one that works really well with younger kids because we've worked on area for so long. It also helps keep our math organized. In this method, we are going to be using what is the traditional digit by digit multiplication, and I like to call this one the parent method. This is the way most parents probably learned how to do double-digit multiplication. It does pose to be a little bit more of a challenge type of math problem. Once you get going on it and you learn how to put in your placeholders, then it's not so hard. So the first step we do is we start with our ones digits. So 8 times 7. 8 times 7 is 56. So I'm going to put my ones digit down. I'm going to carry my 5 next door. Now, according to PEMDAS, I need to multiply before I add. So I still am on my 7. I'm going to do 7 times the 5. 7 times 5 is 35. And then I'm going to add in the 5. So 35 plus 5 is 40. I have now multiplied all of the digits by the 7. So I'm going to cross it out. And I'm going to put a 0 down for my next part. Because now I'm multiplying the 3 by the top digits. But the 3 is really not a 3. The 3 really is a 30. So we need to have that 0 to hold all of our digits in the correct place value. Now I multiply the same way I just did the 7. 3 times 8 is 24. So I'm going to put the 4 down below. I'm going to cross out this plus 5 because I used it, and I'm going to write a plus 2 above it because that's the 24. We carried the 2 over. 3 times 5 is 15, and then we have this plus 2, so that is 17. These are our partial products. We now need to add our partial products together in this problem. 6 plus 0 is 6. 0 plus 4 is 4. 4 plus 7 is 11. Carry our 1. and 1 plus 1 is 2. So we get the answer of 2,146. That method's going to take a little practice. This 0 that we put in for the placeholder once we moved over to the 3 is where people probably make the biggest mistake. And then the other mistake would be when we add the partial products. If we had any carryover amounts, sometimes those get lost in the problem above it. So those are the two common mistakes to look for if you are trying that method. Just like any of these problems, though, the more you practice these methods, the easier they all become. We have a few more methods of multiplication. This unit really is focusing on multiplication, so trying to understand how these methods work. After you really dive deep into figuring out how they all are very similar to each other, sometimes it's a little bit fun to try to make your own method. And a method only works if it gets the correct answer 100% of the time. So the first one's called the place value sections method. This one is the same as that area model. We are expanding out the number, and then we're multiplying. So we're going to find the area of this first box, 50 times 4. And 50 times 4 is just 5 times 4, which is 20. And we have the 0 from the 50, so 200. The next one is 4 times 6, and we get 24. And when we add those two together, we get 224. Okay. The next method is expanded notations method. This one is doing the same concept of these boxes, but with a little bit less of the boxes. So we first take our 74 and we're going to expand it, just like we would have on the top of a box. And then 6, since it's a single digit, it stays a 6. Everything on the top has to get multiplied with everything on the bottom. So the first thing we're multiplying is the 70 times 6, and that's how we get this first row of numbers. 7 times 6 is 42, and we add 1 0 at the end of that. My next one would be the 4 on top needs to multiply by the 6 on bottom. So everything on top has to multiply with everything on the bottom. 4 times 6 is 24. I like to line my numbers up in these columns at the end, so when I add my partial products together, I can get my answer a lot faster because they already were lined up. And this answer is 444. The last one is the algebraic notations method. This one uses the distributive property. The distributive property is when we pass out numbers to other things. So if I have 6 times 76, a lot of times in this first blank, people want to put the actual answer to that problem, but that's not what it's looking for. What it's looking for is we're kind of breaking that problem apart now. The 6 doesn't need to be broken down, so it's going to stay a 6. The 76, though, we need to break that apart because working with 2 digits is a lot harder than working with a single digit and a 0 placeholder. Now I'm going to pass out that 6 times. So 6 times 7 is 42, and that had 1 0 in 70, so 420. 6 times 6 is 36. So we started to combine our information. And now we add these together and we get 456. These three methods are probably, especially the expanded notation and algebraic notation, are probably newer methods for you. These are going to be ones you're going to want to practice a bit more throughout the unit and understand how they are all connected. When I look at the three different methods on this note sheet, I can see my same partial products. I have 240 here when I multiplied my area of 40 times 6. Well, my first problem in expanded notation was 40 times 6. And in algebraic notation, I passed out that 6 to the 40. So I got that first number in the first spot of all of them. In the last one, I did 6 times 9. And here I had the 9 times 6 I passed out. And here the 6 times 9 that I passed out. Because the commutative property says that I can change the order of my multiplication, and it won't change the answer. The next thing we're going to talk about is estimating. Estimating is a great thing to do to make sure that your answer makes sense. So when we estimate, we're trying to get down to just 1 digit times 1 digit. So we're going to round our numbers in order to come out with the 1 digit. So I'm going to round to the highest place value. So in this case, it's the 10. The 5 is going to tell the 3 to go up. So we get 40. On the next one, we're going to round to the tens digit of the 8, and the 2 is going to say stay. So I end up with 40 times 80, and I get an answer of 3,200. When I actually multiply out 35 times 82, I should get an answer that is close to that, if my estimation and my actual answer were done correctly. Let's take a look at our example. In this case, our example has one number in the tens digit, one number in the hundreds digit. We still only want to have 1 digit, so we're still going to round to the highest place value in each of the numbers. In the first one, it is the tens digit. The 7 is going to tell the 4 to go up, so that is going to become 50. And in the next one, the 3 is in the highest place value. The 2 is going to tell it to stay. So I'm going to end up with 50 times 300. I do my 5 times 3, and I get 15. And then I count how many zeros I had. 1, 2, 3. 3 zeros, so I'm going to add those 3 zeros back into the problem. And I end up with an answer that is 15,000. If I were to truly multiply out 47 times 329, my answer should be pretty close to 15,000. Again, this is a good habit to practice to see, does your answer even make sense? All right, we're to the point in the video where it is time for you to practice the problems. Please practice these problems, try them on your own, rewatch the video if you need to, pause it now, and then resume to check your answers. All right, let's check our answers. In the first one, we have 3 times 75. So we are missing the 3, and we have the 75 already there. Both sides are equivalent now. Now I have an equal sign again. I got the 210 by distributing out the 3 times 70. So then my last one is the 3 times 5 to get 15. And then the very last thing to do is combine those and add them together to get 225. My next one, I'm expanding out the numbers in a different sense. I have 30 times 40. I'm going to separate the 3 and the 10 from each other. That make 30. So 3 times 10 gets 30. And then on the other side, 4 times 10 gets me 40. My next one had 4 number spots again. They used the 10 and the 10, but what was missing was the 3 and the 4 from the problem above. So what we did is we just rearranged the order of the numbers. 10 times 10 is what got the 100. What I didn't use yet is the 3 times 4, which is the missing 12. And then 12 times 100 is 1,200. On my next one, if we're going to estimate, our 7 stays a 7 because it's already a single digit. We round the 37 to 40. And 7 times 4 is 28 with the 1 0 from the 40. Then I need to actually solve it out, and I get 259. Now I can sit here and think, maybe that seems like it's far away, but I rounded my estimation up, so my estimation should be up from my actual answer, and it is by a bit. On the next one, use any method to solve 53 times 72. I did the traditional method over here on the side and the area model slash place value sections method there. And the answer is 3,816. The last one, if I have a new theater and an old theater, the old theater had 72 rows of 36 seats each. And the new theater has 98 rows of 48 seats each. How many more seats will be in the new theater? So first I have to multiply the 98 times the 48. And I got 4,704. And I multiplied the 72 times the 36 and got 2,592. I then needed to subtract these to find out how many more. That's a difference word. We are subtracting. And when I subtract out, I get 2,112 seats. Rewatch this video if you need some extra explanation. Otherwise, work on your skills plan of grade 4, unit 2 in iExcel. Try the Math Activity Center lesson checks in math expressions. Otherwise, good luck.